All right, so quiz tomorrow is on 4.1 to 4.3. So we're just going to kind of go through some concepts of what you need to know from each section. And then we've got the practice that's on Canvas for you. And I also, if we can today, I'd like to play Quizlet Live if the Wi-Fi can handle it, okay?
You mean 4.1 to 4.3?
Correct.
Okay. Yeah.
So 4.1 was your congruence and transformations. So this is where you were asked to shift your shapes or resize them based on the different types of transformations. So the first one was a translation. And so for these, if you started with X and Y, to X you were adding or subtracting a number. And to Y, you are adding or subtracting a number. So that would be a translation. You're adding or subtracting a unit onto either the X or the Y. You can just do one. You could do both. Okay? That would be your transformation. Sorry, that would be your translation. And then we had your rotation. And so for these, you started with X and Y, and then there was 3 different ways to shift them. Okay, the first, every single one of them had an X and a Y that were switched. So that, say that the Y goes here, and then the X becomes negative. This is the first kind. And so this is a rotation about 0, 0, 90 degrees clockwise.
Everything's clockwise?
Yep, that takes your points and it rotates them clockwise. So just like your clock would advance, right? Around to the right. Yep. For both of the first 2, you're about 0, 0, and the other one's 180 degrees. Yeah. This video is a video.
Oh.
All right, then you've got it starting at X and Y, and then switching so that it's Y, or sorry, negative Y and X. So again, the X and the Y switch, but this time the negative is on the Y, and this is again a rotation about 0, 0, which means you're kind of rotating it around the center. But this time it's 90 degrees counterclockwise. So if the X gets the negative, it's clockwise. If the Y gets the negative, it's counterclockwise. And then the last one is if it starts as X and Y and it switches so that it's Y and X, but they are both negative. And this is a rotation 180 degrees. Okay, and then the last one is dilation. Yep.
Can it be, what happens if it's rotated 180 counterclockwise?
It won't matter. 180 means completely flipped. So whether it's clockwise or counterclockwise, there's actually no difference. So you'll just say a rotation 180 degrees. Yeah. Oh, not the last one. I still have to do reflection. So translation, rotation, dilation, and reflection. But we'll do dilation. Dilation means you're changing the actual size of your shape. Okay, so if I start out as X, Y, then I multiply either the X by a number or the Y by the number. It doesn't have to be the same number. And it only has to be one or the other. Okay, but this literally changes the scale of your shape. So that if I had a shape that the sides were maybe 1, 2, and 3, let's say we double them and it becomes 2, 4, and 6. That's a dilation. Or cut it in half. Either way, you're changing the size of it. That's a dilation. And then the real last one, reflection. So the reflection, you're changing the sign on just one of them. So if I have x, y, and it becomes x negative y, that's a reflection over the x-axis. So if the sign changes on the y, it's the x-axis. And if the sign changes on the x, then it's over the y-axis. So it's the opposite axis from the letter that's being changed. If the x is being changed, then it's over the y, and if the y is being changed, then it's over the x. All right, so then the second part of this section was determining if the initial shape, the pre-image, and the image are congruent. What does the word congruent mean?
If they have the same, they're equal.
Same, there's two parts to it. Same size and shape. Okay, which means the lengths can't change. So this is all but what? Which one of those transformations would make it not congruent? Dilation. So translation, rotation, and reflection would all stay congruent. Dilation is the only one that would be not congruent. Your shape would literally change size. Those can't be the same, okay? Remember, congruence is same size and shape. So if it's just translated, they're still congruent. If it's rotated, they're still congruent. And if it's reflected, then they're still congruent. They would be not congruent if there is a dilation. So if we've changed the size of your shape.
Wait, so if there was a dilation, it would be
Not congruent.
Translation, rotation, or reflection would be congruent.
Exactly. So you'll get this in two different parts. One is, given the type of transformation, plot your new points, give the new vertices, and then describe the transformation. So you've got to be able to identify from your points what happened, what was the transformation, find the new ones, and then give those points.
So we have to put that they're congruent in the end.
Then the second part is going to be, here's two shapes, determine what the translation is and if they are congruent or not. Questions, so that's 4.1. Questions on 4.1. Expectations from 4.1, kind of questions. Okay, good. Well. Okay, 4.2 is classifying triangles. So we learned two ways to classify the triangles, by their angles and by their sides. So if I want to classify them by their angles, I had acute, right, obtuse, and equiangular. How do I know it's acute?
Less than 90.
Good. All angles less than 90. How about right?
90 degrees.
One angle equal 90 degrees. Obtuse?
More than
One angle greater than 90 degrees and equal angular.
all angles are.
Good. A great question, and sometimes it will say there's more than one way to classify it. You need to write all of them. So an equiangular triangle will also be acute because all the angles will be less than 90 degrees. Less than 90 degrees. That none of the other ones can overlap. It can't be acute and right and obtuse or acute and obtuse. The only ones that can be both is if it's equiangular, it is acute.
What about two?
Nope. Equiangular, they'd all have to be 60, so it can't be obtuse.
Question.
Mm-hmm.
Quiz?
Yep.
How are we going to be able to determine if it's asking for, let's say, something equilateral or equal?
It'll say classify it by its angles or classify it by its sides.
Alright.
So it's pretty straightforward. Okay, so then the second way we grouped was by sides. So we had scalene. Good. Isosceles. and equilateral. So there's only 3 classifications by sides. 4 by angles, 3 by sides. What's it mean to be scalene?
No equal sides.
No equal sides. So all the sides are different. Isosceles.
2 equal sides.
At least 2, right? At least 2, which means it could be 2 or it could be 3.
Wait, how would it be 3?
Because if it's equilateral, it's also isosceles.
Okay.
All right, and then 4.3 was angle relationships in triangles. So there were a bunch of corollaries and theorems in this section having to do with the angles inside the triangle. The first one was the triangle sum theorem, which said what?
That angle A will be an angle C to 180.
Good. So all 3 angles in a triangle sum or add up to 180 degrees. Your quiz review. Then you had the corollary that didn't have a name, but it started with acute angles of a right triangle. How did it end? What's true about the acute angles of a right triangle? Good. What's another word for 90? Or add up to 90? 2 angles. Good. They're complementary. So if I'm told that a triangle ABC is a right triangle and it says angle B equals this, angle C equals this, and angle A is the right angle, I know B plus C equals 90 degrees. Then there was one that again didn't have a name, but it started with the measure of each angle in an equiangular triangle would equal what?
60.
Good, 60 degrees. So again, these didn't have names. Then you had 2 that had names. Exterior angle theorem, which said the exterior angle on a triangle is equal to the sum of the remote interior angles. And that looks something like this. And I would say that the angle 1 equals the sum of what 2 angles? What's remote interior mean? 3 and 4, right? The ones that are non-adjacent. Okay, remote interior means not next to, because 1 and 2 already have a relationship, right? What's the relationship between 1 and 2?
Or they're supplementary.
They're supplementary because they're a linear pair, right? So the one that would be the sum would be 3 and 4. So angle 1 would equal 3 plus 4. And then the last theorem or corollary in this section is the third angles theorem.
So they say angle 1 is 40 for the one above.
Yep.
Would 2 be 40?
No, they're not necessarily equal. If you knew 3 and 4, you could find 1. Or if you knew 1 and 4, you could find 3. So you have to have 2 of those 3. All right, so the third angles theorem says if 2 angles in one triangle are equal to 2 angles in a second triangle, then what do we know? What's the third angles theorem tell you?
That the third angles
Good.
equal to
Then the third angles in each are also congruent. So an example, sloppy example, but an example of that would be something like you see there. So because C is equal to E and B is equal to D, what can you determine from this shape? Good. Angle A would be equal to angle F. So obviously there's going to be some algebra in there too, where you might have to use, an expression set it equal to each other. But the concept is what's going to get you there. So here's an example of the exterior angle theorem, right? Which would say 120 would be equal to the sum of these two interior angles. So 40 and x plus 10. So then I get 120 equals x plus 50. And then subtract the 50 from both sides. And x is 70.
So that corner is 70?
So the x is 70. This corner would be 80, right? Which makes sense because 80 plus 40 has to equal that 120.
Excuse me, may I go to the restroom?